Hello, everybody, and welcome to the G2M Research Multi-Vendor Webinar. This webinar is focused on what features are important in all-flash arrays in the era of NVMe and NVMe over fabrics. Our sponsors are Western Digital, Toshiba, and Quantum. A little overview of the webinar agenda. So the first few minutes, I'll introduce the topic and go through the ground rules. After that, each webinar vendor will talk for about 7 minutes. We'll then have 3 questions that we ask the webinar vendors and 3 audience survey questions that we'll interleave with those. At the end, we'll have a Q&A session. We'll wrap up. The webinar should last till about 10:15, 10:20 or so. If you have questions in the audience, please use the Q&A window in Zoom to submit your question, and we'll answer those questions at the end. So you can put them in as you see them, but we'll hold off and answer them until we get to the end. Another thing is that when we're doing the polls, there is a polling window that you can bring up that you can actually answer the questions on, so please do that there. That way your answers will get recorded. Finally, the webinar will be recorded. It is being recorded right now, and we will make that recording available to everybody who registered for it, along with a set of slides. Those should come out sometime Thursday, probably about mid-afternoon or so. So anyway, we'll send those off, and with that, let's go ahead and get started. So with us today are Narayan Venkat. Narayan is the VP of Data Center Systems at Western Digital. He was formerly with one of the companies that Western Digital bought up recently to get into that space. Also with us is Jason Quarry. Jason is Global Director of Products and Solutions for Quantum. Also with us is Matt Hallberg. Matt is a Senior Product and Marketing Manager for SSDs at Toshiba, and I'm Mike Human, the Managing Partner at G2M Research. So the question that we oftentimes hear is, what is an NVMe all-flash array? And the way that we've kind of defined it, which more or less works along the same ways that the industry has, is an NVMe all-flash array is a storage array utilizing flash storage as its media and solely flash storage. So it's an all-flash array in that respect. And that also utilizes NVMe flash storage media, utilizes NVMe over fabric protocol for its back-end communications with the flash storage enclosures, and or utilizes one or more NVMe over fabric protocols to communicate with initiators. And you can see systems where you'll see one of these things. We use 3 generally NVMe all-flash arrays using NVMe flash media. There are some that use standard protocols to speak with initiators, and there are some that use standard back-end fabrics as well. But I think everybody sees the industry going towards using all 3 of these to accelerate performance. And some of our users will talk about that as we go on to this. So NVMe over fabric host interfaces can include NVMe over fiber channel, NVMe over Rocky, NVMe over TCP, and NVMe over InfiniBand. The 2 that we see, or the 3 we see the most utilized, tend to be NVMe over fiber channel. That's almost a freebie in the sense that if you're already using fiber channel, all the Gen 6 adapters and beyond all provide NVMe over fiber channel, so you get that for free. You know, NVMe over Rocky certainly is one of the earliest ones that people have used in this space. That's one that came up quite a while ago. And it's probably the leader on the Ethernet side. We're starting to see NVMe over TCP come up. And NVMe over InfiniBand typically is used in the HPC world. Just like standard all-flash arrays or arrays in general, many arrays support multiple host interfaces. So you can see an array supporting fiber channel, Rocky, TCP, and InfiniBand potentially, all of those interfaces together, or at least offering them as options. How do NVMe AFAs differ from SAS SATA AFAs? So one of the big differences is performance and latency. Obviously, NVMe SSDs provide a lot lower latency than SAS SATA SSDs because of the fact that their protocol is not based on SCSI like SAS and SATA is. It's based on NVMe. Similarly, the NVMe over fabric protocols tend to have much lower latency than the SCSI-based protocols, say, of fiber channel or iSCSI or things like that. And these things really enable NVMe AFAs to provide a lot higher performance than SAS SATA AFAs do, both from a latency standpoint and a throughput standpoint. One of the other big differences is scalability. So back in the days of SAS SATA, if you use that as a backend fabric, at best, a JBOD could be shared by two, front-end controllers. With NVMe, you can build a real fabric in the back end of your combination of your arrays, your storage infrastructure. That allows things like software composable storage infrastructures to happen. It allows things like being able to move around just a bunch of flat JBOFs from one controller to another, or have them shared across multiple controllers. So it gives people a lot of flexibility that we hadn't had previously. I think the final thing that we've seen happen over the past year is today every AFA vendor out there has at least one NVMe all-flash array in the market. And I think we'll see over the next 2 to 3 years that those become the leading all-flash array fabrics. But we'll let our vendors talk more to that. So what is this webinar going to focus on? There's really kind of 4 things we're focusing on. One of them is what we can call data management. If you look 20 years ago, and you looked at the way people talked about storage arrays, it was capacity, it was performance, and it was RAID levels. Those are the 3 things that people really had the capability of doing. If you look at then what happened, say, 15 years ago, you started to see data management features such as backup and replication, dedupe, and compression come along and started to become important. 5 years ago, we saw all-flash arrays appear. Performance again became important at that point, especially latency for a lot of the use cases that all-flash arrays first targeted. You also saw concepts like data locality and encryption start to come up, and those drove down to some extent the importance of deduplication and compression. What we see today is that NVMe MI or NVMe management interface provides a lot of capabilities such as partitioning and things like that that were not previously in the protocols that existed today. So what we want to really talk about is how important are data management capabilities in NVMe all-flash arrays today. And with that, I'd like to turn it over to Narayan. Narayan is Vice President of Data Center Systems at Western Digital.
Hey, thanks, Mike. If you don't mind, can you kindly build this out, the slides as we go along?
Okay.
So at a very macro level, and for those of you in the audience that have been in IT or sort of ran an IT organization or an infrastructure organization, it's clearly the biggest challenge is, how do you have an infrastructure that delivers sort of timely or enables delivery of timely insights? Does your infrastructure deliver what the business line wants, right? And more so as we look out, in fact, going back to what Mike was saying, if you looked at the last 10 years and you look forward, another 5 or 10 years, infrastructure is going to continue to be critical going forward. And the real essence of this comes down to, can your infrastructure deliver timely insights, and i.e. what the business wants? Can we process more data, more applications, right? Can we accelerate workloads? And more importantly, which is, how do I manage my data sets? Data is obviously crucial to the business, the line of business, the applications, et cetera. So how do I handle data protection, data management that most enterprise customers have gotten used to? How do I back up? How do I recover? How do I mobilize data? And how do I provision data across a wide range of apps? So net, infrastructure continues to be critical, and everything needs to be stored and analyzed faster. So that we kind of all know. And why is this important? This is important because, and plays right into the heart of the whole NVMe discussion. So Mike, next slide, please. So let me sort of back up a little bit. So at Western Digital, we've been in the market, and Mike was referring to earlier, I was part of a company called Tejal Systems, and we were in the market since 2010, delivering hybrid, all-flash, and now NVMe flash arrays, and we got acquired into Western Digital. And over the last sort of 10, almost 8 to 9 years that we've been in business, what we've seen is customers want to adopt the latest, greatest, fastest infrastructure, but they do not want to give up on the classic data management capabilities that they've gotten used to, i.e., How do I, do snapshots? How do I do clones, right? Can I leverage inline compression and deduplication so as to reduce my cost of an all-flash infrastructure, right? They still want to be able to do storage pooling, thin provisioning, all of the things that we have fundamentally got used to. So customers don't want to give up on any of those. And that's essentially driven most vendors, whether it's us or our competitors like NetApp, EMC, Pure, and others, to deliver all of the capabilities that typically one would see in an enterprise storage array. So think about sort of end-to-end data integrity. I mentioned snapshots and clones, right? Asynchronous replication, synchronous replication, multi-parity RAID, right? So or erasure coding. And then, if you couple that with what Mike just said, like encryption and, data placement, data locality, it becomes actually a full-fledged storage system. And that's kind of what customers really want. In addition to that, what customers are now asking for is, how do I monitor, manage my infrastructure? How do I get more autonomous in terms of avoiding maintenance windows? Can we get more predictive? Can we have predictive analytics built into the array? So in essence, if you go back 10, 15, 20 years, or even more longer than that, what enterprise storage systems delivered, today NVMe AFAs are delivering the same thing. So in essence, all vendors have been working to optimize their software so as to take advantage of the NVMe interfaces and leverage what the flash media has to offer in terms of performance and resiliency. Mike, next slide. So what have we seen in the market? So we've been, in business. We've got about 2,600 customers, about 3,800 systems in the field across a wide range of apps. And I mentioned earlier, we came to the market originally with hybrid flash systems, and then subsequently delivered AFAs, and now NVMe AFAs. We've been in the market with NVMe AFAs for about a couple of years. And what you would expect is that NVMe AFAs are starting to take on those applications that are fundamentally more latency sensitive. So I still see that NVMe AFA, there's still a price premium between SAS AFA and NVMe AFAs. And so customers are deploying NVMe AFAs for low latency apps, as you would expect, but they're starting to rapidly expand NVMe AFAs into more traditional and mainstream workloads. So think about databases, analytics, large scale virtual server farms, right? And so if you look at the breakdown of how, the sets of applications deploying on what type of storage, essentially this is kind of what we're starting to see. We're starting to see hybrid arrays or hybrid flash arrays, which include a combination of flash and spinning media, fundamentally taking on secondary storage apps. SAS AFA is still, the bulk of the AFA business, but being sort of slowly pushed towards virtual apps, application infrastructure, and then NVMe AFA is starting to take on more of the latency sensitive infrastructures. And what we're seeing is the bulk of NVMe AFAs today are deployed using standard protocols, which is fiber channel and iSCSI, and in many cases over Ethernet using file protocols. But the market is in the early stages of starting to deploy NVMe Fabric with NVMe AFAs as targets. And the early stages that we've seen, is NVMe over TCP. NVMe over fiber channel. TCP is still in the very, very early stages. Mike, next slide. So a little bit of a vendor speak here. This is our portfolio. Again, many of you may be familiar with, obviously we start with NVMe data center drives, going up in memory extensions to flat storage systems or storage servers. On top of that, our composable infrastructure, what we call OpenFlex, and IntelliFlash arrays. These are enterprise NVMe AFAs in the true sense, meaning runs a high-performance storage software stack and provides the entire data management capabilities. Mike was referring to something earlier about composable infrastructures. That's our OpenFlex product. Think about them as NVMe over Fabric JBoFs, although you can add both flash and spinning media in that. But essentially, think about these as JBoF, which are provisioned over NVMe Fabric. And that allows us to essentially build, scale up and scale out flash arrays. Mike, next slide. So let me sort of dive a little deeper in terms of our Intel Flash portfolio. There's only 2 slides, which would give you a sense of what we have to offer. Essentially, we've got a portfolio of products. On the extreme left, you see SAS hybrid flash arrays, which include a combination, SAS flash and spinning media. And as you move to the right, HD series is high density SAS-based AFAs, and then the N series, which represents the NVMe flash arrays. So clearly, the price performance here matters. On the extreme left, you're looking at higher millisecond latencies in 1 to 2 milliseconds. And on our N series box, we deliver 200 microsecond latencies at over 1.7 million IOPS. So you can see that substantial performance gains. But one key thing for us is it's the same operating environment that we run across all these platforms. So customers may start with one, expand into another, but they get the same feature set and data management capabilities. Next slide, Mike. So what have we done? I mean, there's often this question about, you need to run data management services. It isn't about just raw NVMe. I mean, gone are those days where, from an AFA perspective, where you just had high performance AFA would deliver performance. But today, customers expect a full suite of data management capabilities. So the key thing that most vendors work through their software stack is how do we optimize the latencies and data paths, right? So fundamentally, our architecture is such that we've split our software stack to essentially look at media in different classes. As you would expect, a high performance tier, call it persistent memory. I mean, today SCM is in the very early stages. We don't have it yet, but most storage vendors use NVDIMMs. So think about that as a persistent memory tier. There's a performance tier, which is NVMe, or it could be SAS Flash, and a capacity tier, which should be SAS Flash or HDD. So our software stack, and I think it's pretty much similar to other vendors who look at this problem in this way and saying that, how do I deliver the bulk of my I/O coming from the highest performing tier? And so there's a substantial amount of software work that has been done over the years to essentially accelerate all data services. We split metadata from application data, lay them across the right set of media, can do inline compression and dedupe, at the speed and scale of what the media offers. So the bulk of the work essentially comes down to how do we optimize the software stack that gives all of those capabilities that I just mentioned, but extracts the maximum value from a performance and a latency standpoint from what the flash media offers, and more importantly, over NVMe. Mike, next slide. So what that does, next slide, please. What that does is, what that does is, it naturally sort of falls, in more of a pyramid, where the NVMe arrays or AFAs are predominantly used for low latency apps. Now, the interesting thing is, many vendors, and I'll speak for Western Digital, we allow customers to mix and match media types so that you can optimize performance and capacity and economics. So you can start with an NVMe AFA, add some SAS Flash to it, etc. Doesn't have to be all NVMe. So different vendors have taken different approaches to essentially balance performance, capacity, and data management features so that you can run a plethora of different applications that you typically find in an enterprise environment. Next slide, Mike. So just as an example, where we've seen success, I mentioned, right, we have about 2,500 plus customers, 3,700 plus systems deployed in the field. I've sort of anonymized some of these names, but in essence, what we see is customers deploying NVMe AFAs primarily for low latency real-time decision making. A few examples here. We've got customers in the Formula One ecosystem where it is all about latency of decision making. Our arrays are in the actual Formula One circuits, and it is about doing real-time analytics. Other places where, customers have deployed NVMe systems for basically sub-millisecond response time, consistent sub-millisecond response times. So that's what you would expect typically, and customers are starting to deploy NVMe AFAs into many of their mainstream apps without having to compromise on any data management or data protection capabilities. I think those are that's my last slide, Mike. Yep. So
thanks for more,
visit us, and you can learn all about Intel Flash NVMe arrays on the Western Digital site.
Excellent. Thank you. Okay, Jason. Jason's Global Director of Products and Solutions at Quantum. Jason, you've got the floor.
Fantastic. Thank you, Mike. And thanks, everyone, for taking time out of your day to join. So what I thought I would do is talk about NVMe from the perspective of improving the overall economics. I think, everyone on this call, we're very well versed in the kind of performance enhancements that NVMe can offer. And certainly Flash even offers other things, benefits to organizations, things like reliability, things like overall TCO, and improving aspects of the data center. And so I thought I'd try to bring some of that to light because, if you think about Flash just from the perspective of dollars per terabyte, it is a very expensive storage media, but there's several things that the storage vendors are doing, including Quantum, that are trying to make this more economically viable and better aligned to basically the workflows that we're using Flash for. So to actually build off of what Narayan at Western Digital was talking about, Quantum as well really has put a lot of emphasis into primary storage tiering. We've actually always offered tiering with our products and the ability to basically tier colder data or less frequently used data into an archive tier, offering our customers flexibility either to put that archive data on premise with tape libraries or object storage, or up into cloud, take your pick. Whatever your use case is, we'd be able to offer that, and that substantially improves end-to-end storage economics. But with NVMe, with Flash-based technology, and trying to unlock more value on the primary storage tier, we've been putting a lot of investment into our own file system to allow our customers to do this. And so this is basically making sure that the data that's the hottest, the projects that are really where the performance requirement is aligned, those projects are sitting on the fastest storage. So we're really enabling customers to best align their storage assets to the value of the data that is actually sitting on those assets. And so at Quantum, we call this storage pools. It's file content based. It's not block based. This can be all the data movement can be either user controlled. It can be automated by IT policy. It can actually be also automated by MAMs or media asset managers. But the idea is that this is really transparent to users. And so they're not really aware of what tier their data is sitting on. What they know is that it's being served to them in with the requirement of the application they're running, and it basically meets that requirement. So this is kind of an enabler for Quantum to really build out hybrid storage infrastructure. So I'll talk about that in the next coming slide. So Mike, next slide, please. So looking at this from an end-to-end perspective, basically Flash-based solutions can offer a number of impacts. We all are aware of the performance impact, but there's also substantial impacts when it comes to power and cooling, and that translating into dollars being saved. Certainly some better ROI of storage assets, especially as Flash-based solutions typically increase service life of those assets. You've got operational impacts. The idea that a lot of our customers, especially in the media and entertainment industry, to deliver the performance that's required with spinning disk, they typically have to over provision their storage, which can end up taking, is not a good utilization of those disks. And typically the amount of rack space that's required to achieve the performance numbers, it's much greater than flash. Also, one fantastic thing that NVMe is allowing customers to do, and we're seeing a number of this transformation happening, is customers moving what typically used to be fiber channel based workflows and moving that over to Ethernet based. NVMe is really providing the horsepower to allow that transformation to happen. And of course, with Ethernet based networking, there's quite a bit of financial impact with that, not to mention operational and management savings as well. And then ultimately, NVMe based storage ultimately delivers a business impact, completing deliver projects faster and, of course, more on time. So let's take a quick look at just the financial impact. So Mike, next slide, please. So what I'm going to compare is actually a storage array that QXS storage is Quantum's. Basically, it's our block storage arrays. They can be configured anywhere from SSDs to nearline SAS, 10K 2.5 inch drives, a variety of form factors and configurable options. And so we actually architected a solution based on an aggregate performance capacity requirement by a customer. We architected that solution as a 100% spinning disk solution to meet certain throughput and capacity requirements. What was required was essentially over 21 gigabytes a second throughput and at least 250 terabytes capacity usable. When we initially architected that solution at the price point you see there, it was $155,000. With storage pools and that software technology that I mentioned in the first slide, we're actually able to architect a hybrid solution where you've got a performance tier of storage. This is using our F2000 100% NVMe storage array. It's a little 2U box, comes between 46 and 192 terabytes capacity. And we couple that with a much slower nearline SAS block storage array. But overall, in aggregate, it actually delivers more throughput and higher amounts of capacity as a hybrid storage solution. So what NVMe is starting to allow customers to do is actually really change the economics of end-to-end storage solutions. So I think it's actually pretty fascinating. You're actually using NVMe not in spite of the price penalty, but actually because of the cost advantage that it's providing. Mike, next slide, please. Taking that financial impact further, I wanted to demonstrate basically, if you think about infrastructure cost and what goes into that, you've got quite a big percentage in networking. You clearly have storage hardware, and then you have storage software. So SAN-based storage infrastructure or fiber channel-based storage infrastructure, because those switches are so expensive, you're typically spending in a storage budget, at least Quantum sees this with a lot of our customers, at least 50% of your entire storage budget went into your network. If you're able to move that into an Ethernet-based topology, say using 100 gigabit Ethernet connectivity, you can spend much less on the network and actually spend a greater percentage of your budget on the storage hardware. Of course, your storage hardware is really what's going to be driving your throughput. It's what's going to be driving your capacity. So overall, you're probably going to have a much higher performing solution at the same cost, or a less expensive solution that provides the equal amount of performance as the fiber channel solution. So another basically thing to consider when migrating to NVMe-based solutions. Mike, next slide, please. So I have just 2 slides left. One is to talk a little bit about the use cases. I wanted to specifically talk about M&E use cases because really Quantum is quite the specialist with preserving and providing access to video and video-like data. So we have a number of M&E customers, very large post houses, movie studios, broadcasters, et cetera. These kind of customers are coming to us because the resolution of the content is rapidly increasing. And to really, for the editors to be manipulating that content real time, they're really requiring higher performance solutions. And so that's one very good use case for NVMe-based solutions because of the performance requirement that's needed to drive those kind of workflows. And broadcast, one thing that Flash is absolutely terrific for is basically high IOPS and lots of random workflows, right? Random reads and writes. And in broadcast, if you're running multiple ingest streams off of multiple cameras and you want to work on that content real time, you need that kind of performance capability. It's a little bit less about throughput. Again, it's more about IOPS, and that's something that NVMe can certainly offer. And then finally, with visual effects, analysis, simulation, environments that are very typical in HPC and research, that's another area where a lot of times, years ago, storage was not keeping up with the render farm, with all the compute nodes. NVMe allows those processors to write without any contention to the fast pools of storage in real time. So we see a lot of use cases and adoption in that area. Mike, final slide, please. And then I just had one slide on, this is Quantum's offerings for NVMe. We have just launched a product in April. It's called our F2000. It's a 2U server with 24 dual-ported NVMe drives. It's configured for high availability. Each one of the compute canisters has dual processors, and all those processors have access to those drives. You can access content via fiber channel or 100 gigabit Ethernet, so you can have the connectivity choice that basically your business needs. Throughput is over 25 gigabytes a second, which for a 2U box is pretty outstanding. This is powered by our own block storage stack. We call that the Quantum Cloud Storage Platform. And when you think about data services, we've actually stripped out a lot of data services that typically aren't required in video workflows. And we really kept a very simple stack in to really maximize the performance of the video-like data with this kind of solution. And it's integrated with our StoreNext file system, which allows this solution to be put into hybrid architectures with slower spinning disk in an archive tier, and really used as a building block to really put a really optimized end-to-end storage workflow together. So that's Quantum's take at NVMe, and I turn it back over to you, Mike.
Thanks a lot, Jason. That was a really good presentation. Last up, we have Matt Hallberg. Matt is the Senior Product Marketing Manager for Enterprise SSDs at Toshiba. Matt, take it away.
All right, thanks, Mike. Hey, guys, my name is Matt Hallberg. As Mike said, I manage the enterprise SSDs over at Toshiba, mainly focusing on our NVMe offerings. And today I wanted to go about this presentation a little bit different. You guys have heard from the platform guys who are actually making AFAs, and we're bringing a different perspective in, which is from the SSD side of things. So, first things off is, we're talking about NVMe AFAs. Well, NVMe SSDs are an important ingredient in an NVMe AFA. So all flash arrays are built on the premise that by moving away from traditional hard drive and hybrid arrays, the end user should see large increases in performance. And you will see in an AFA with SAS or SATA SSDs a large performance boost, especially if you're going from a hybrid AFA or a bunch of spinning media. But one thing to keep in mind is that all SSDs are not created equal. The SAS and SATA SSDs and the interconnect technology required for it, that'd be SAS or serial ATA, are all based on legacy storage protocols. If there's any old school storage guys on the calls, they might remember what AT and SCSI are. Have been around for 30 plus years that were made for hard drives. They didn't care about latency. They didn't care about throughput. They cared more about architecture. NVMe itself, though, was architected from the ground up to address the performance and the latency benefits from working with flash. And also, there's the direct nature of communication with the host. and scalability of performance from the PCIe bus. So you could have drives connected at by 2, by 4, by 8, and basically double your throughput if you have an SSD that supports those speeds in an instant. So the real key tenets of an NVMe AFA, and that you should expect out of any NVMe AFA, is performance, parallelism, and latency. Please go to the next slide. So for the NVMe SSDs, these are what the key features are. Obviously, low latency is at the top of the list. Everyone hears that NVMe has low latency. It is required for heavy lift applications like data analytics or e-commerce. If you can imagine going to an e-commerce site that's run from a AFA storage array with CPU clusters and everything else, if you're clicking on a link to try to buy something and the link takes forever, well, low latency or high latency means I won't be returning back to that site. NVMe SSDs also feature high performance. So, the SSDs need to be able to cover the wide variety of workloads for high intensity applications. So you want to be able to work with things like databases, with virtual machines, AI, you name it, and you need an SSD that is able to cover those different kinds of workloads. Dual port is also super important inside of an AFA. That means that relates to the drive being highly available and reliability. So if a server goes down, you have another path to talk to the drive. Parallelism just means that there's a support for a super high queue count. So you're managing thousands and thousands of tasks or high queue depth in parallel. The density is also important. So in AFAs, there's a trend of moving away from lower capacity drives that were comparable to hard drives, like a 4 terabyte drive to a 4 terabyte SATA drive, and to higher and higher capacities on SSDs. Most NVMe SSDs in the market today can hit the cap capacity of about 15 terabytes. Data integrity is also important inside of the SSDs, which is support for the protection information via diff-dix. And then security is protecting your data with the latest encryption standards. And there's actually a question later on during the forum or the panel discussion that talks about this. And then lastly is disk management. So Mike had a small bullet point in his slides above that talked about NVMe MI. This is a way of talking to the drive via sideband to get its statistics or what temperature it's running at, etc. Please go to the next slide. So these are the use cases inside an NVMe AFA that are greatly improved with NVMe SSDs. Some of these may apply to the people on the call today. If you have anything to do with databases, database applications are greatly improved with a low latency and high performance of NVMe SSDs. So your TPMs will shoot through the roof, and your average cost per TPM or your cost per transaction should reduce greatly as well. If you have anything to do with containers, that includes Docker, Swarm, Kubernetes, etc., that's improved with the high performance and the large queue depth in the random read and random write workload environments that you'll find in container deployments. Data analytics, which includes Splunk, Hadoop, HANA, Spark, etc. If you do any of the dense or sparse searching, the kind of traffic workloads you'll see there require high sequential and random read performance, and that is a specialty of NVMe SSDs. And lastly, if you're doing any kind of object storage, there's Ceph, Swift, Gluster, Lustre, etc. Everything about NVMe, the performance, the latency, and the capacities will greatly increase the number of applications that the cluster can support. So, when you buy an AFA, if you can't support doing everything, that kind of sucks. But if you buy an AFA with NVMe SSDs, you'll be able to support a lot more different kinds of applications with it, increasing your investment. Okay. So what about us? What do we offer for NVMe AFAs? Well, we have NVMe SSDs. This is the CM5, and I do get a little bit to talk about my own product line. It's a consistent performer with reliability and demanding 24/7, 24 hours, 7 days a week environments. The QoS is fantastic for those of you who are involved in SLAs, and it's designed for high density deployments. Some of the key features are end-to-end data corruption, NVMe. There's this feature called SIRS, which is reference clock. The PI that I was talking about is supported. There's namespaces, dual port, multi-streaming. If you're doing anything with VMware, we're VMware certified. And then on security side, we support secure incident array, sanitize, TCG Opal, and FIPS. And then there's some performance numbers here on the right. And in the interest of time and catching us back up to the schedule, I'll go ahead and gloss over those. But it's a fantastic drive available with endurances of 1 drive write per day and 3 drive write per day. So we're able to fit the different kinds of workloads. So with that, I'll go ahead and turn it over to Mike.
Thanks a lot, Matt. I think you really hit some really important points that kind of showed how important the drive itself is within the overall array. I'm going to go ahead and launch the first poll, and while we do that, I'll give you guys a couple minutes to answer it, but we'll also go ahead and start go to the first audience survey question, or the first panel question as well. And that panel question is, how do NVMe and NVMe over Flash change what the important features are in an all-flash array? And we'll give each panelist a minute or two to answer it. We'll go ahead and start with you, Jason, at Quantum. Jason, are you there?
Oh, yeah, sorry about that. Yeah,
no worries.
Yeah, apologies. So I think really what NVMe and NVMe over Fabric change is that I think balance is quite important in a storage environment, storage infrastructure. When you think about end-to-end storage requirements, and if you think that NVMe in many ways turbocharge, basically all flash array performance, there therefore needs to be a counterbalance to that in other parts of the storage infrastructure, because there's few workflows that I know of that just require 100%. Maximum performance of NVMe at all times. There's some out there, but not many. And so I think what just needs to be considered is that as we build out the storage infrastructure and we have a tier of NVMe, is really dialing in for all those on the call who manage your own environments, what percentage of users really have that performance requirement, how many projects have that performance requirements, and then architect the storage solution accordingly so you're not spending too much overall and you can get a better ROI on your overall storage investment.
Excellent. Matt, what do you think from the Toshiba? I know we talked a little bit about this, but what are if you had kind of sum it up in a sentence or two?
Yeah. So for me, the NVMe over Fabric and NVMe are really, they're game changers in that they're changing the way AFAs are architected. They're changing the way software works. There's been all these crazy fantasies in the storage world about low latency, high performance, high reliability, and when you look at typical AFAs, it's easy to put a HBA that supports NVMe into a box, but when you get an NVMe over Fabric, it changes everything. And the storage is no longer the slow point in the system. The NIC with the newer NICs that are coming out are no longer the slower piece of the architecture. Everybody's having to put on their game face and go innovate and make software and firmware that takes advantage of NVMe.
I think that's a really good point. And I do remember the days when the storage was the slow part of the whole system, and certainly that's largely gone today. I think if anything, it's the network today. Narayan, what do you think? What would be your answer to this question?
All right, you might be on mute.
Mike.
There
you got me muted, Mike. Mike didn't want to hear from me. No, as Jason and Matt said, right, it really comes down to software optimization. So the way I look at this is, if you have a substantial amount of performance at your disposal, and NVMe is all about reduction in latency. What changes, are two things. One is you're going to see substantially greater consolidation of different types of apps on an AFA, and we've seen that in traditional sort of SaaS-based AFAs. When you compare that to legacy storage, you're going to see the same thing with NVMe AFAs. So when you see substantial amount of consolidation, then deterministic performance, deterministic latency in the context of data management becomes important. In other words, I think Matt was, or was it Jason, or Matt was referring to things like containers, right? I want to be able to snapshot and clone a container and a data set associated with a container at whatever speeds and latency that's required, right? I want to be able to mobilize the data from, let's say, one node to another. And I think NVMe over Fabric allows you to do that because now you're on a shared backend and a shared backplane. So software architectures and software optimizations have to be done so that the core data set, data management features. So think snapshots and clones, think inline compression and deduplication, think data mobility, think failover characteristics. All these will undergo and actually have undergone a substantial amount of change, right? But at the very macro level, applications that have gotten used to using a set of data management capabilities, those won't change. It's just that it's going to run more predictable, much faster with substantially lower latency.
Excellent. So let's go to the second audience survey question. I'll go ahead and launch that. And this question is, are there use cases you'd consider using an NVMe AFA for, even if it didn't have the same data management services that non-NVMe AFAs have? And this is a check one response. And with that, we will go to the second panel question as well. And that question is, how important are features such as deduplication and compression going forward, especially when compared to security features such as encryption and access control and monitoring? And we'll start with Matt at Toshiba.
Yeah, so the dedupe and compression are really handled at a different layer than the SSDs. So I think the expertise is going to be passed over to the other speakers on the call. However, when we talk about features such as encryption and access control monitoring, that kind of stuff is coming down to the SSDs. So that being said, features like inline deduplication and compression are useful. You just got to make sure that within your AFA you have enough computing power to cover things, especially if you're doing something that's CPU centric like AI. Encryption is definitely coming down to the SSDs, and that's going to relieve some of the system resources and some of the software resources required to do it at the system level. And that's really all I have to say about that.
Okay, Narayan, what do you think?
Yeah, I don't think this is a this or that, meaning from an economic standpoint, dedupe and compression are absolutely crucial, right? For AFAs in general. It's not necessarily NVMe AFAs, but AFAs in general. That said, there are lots and lots of customer deployments in different industry verticals and segments of the market where data security and encryption is absolutely key. And as as Matt said, software stacks have sort of stayed away, or I've basically handed off the encryption capability, to the devices, the drives. So we use SEDs as an example. So I wouldn't necessarily say that one is more important than the other. It's clear that people want encryption, but it's also a given that most SSDs now are delivering native encryption capabilities. So one is about data security, right? And that's actually paramount, right? If you put a gun to my head and say, hey, which one would you want before the other? If money weren't, or if economics weren't that much of a concern, I would take encryption over compression and dedupe. But that said, it's always a balance, right? So encryption kind of gets, in my mind, a given in that most vendors are delivering encryption natively on the drives. So dedupe and compression become important from an economic standpoint.
Yeah, I think the idea that you can do different things at different levels within the system is an important one as well. Jason, what are you guys seeing at Quantum on this question? You certainly deal a lot with things that need compression, and so I imagine you have a lot of experience on this one.
Yeah, we do. I think it's a great question, and but I think the honest answer moving forward is each one of these is fairly important. Dedupe, compression, encryption, security of data, protecting the data, and then making the most of the capacity within your storage infrastructure, because it's not like budgets are increasing exponentially is rather important. But what's happening is I think some of the vendors are providing the different technologies to accomplish some of the security and protection goals, and we're introducing different techniques to deliver these kind of capabilities. I also would say that with for example video and video-like data, that kind of data is harder or nearly impossible to deduplicate. So what we're finding a lot of customers doing there is erasure coding, and at Quantum we're actually working on erasure coded tape libraries and thinking about how can we make tape libraries more resilient, but even more economically viable and almost a scale-out approach there. I think from a compression standpoint, we have a lot of our media customers that continue to work in those kind of formats, and compression specifically is a format that takes a lot of advantage of NVMe, right? The data rates are a little bit smaller than uncompressed formats, and yet what that typically means is they're dealing with more streams of data, something that NVMe excels providing the performance for. And then finally, I would say with data security and encryption, as my colleagues mentioned, with self-encrypted drives, with things in the file system like versioning and automated copying, there's all sorts of ways that we can help customers protect data, and it's going to continue to be paramount in their making sure they architect a solution that can provide that benefit. So that's Quantum 2.
Excellent. So let's go ahead and launch the final question for the audience, and that question is, what do you see as the greatest challenges to implementing NVMe AFAs in your organization? This is select all that applies. So with that, let's go to the final panel question, and that is, what do you see as the timeline for mass adoption? In other words, 50% or more of new models sold for NVMe and NVMe over flash in all flash, or NVMe over fabric in all flash arrays. And Ryan, we'll start with you on that one.
Yeah, it's a very interesting question, and I actually want to compartmentalize my answer on this, meaning we're starting to see an increase in adoption of NVMe AFAs, distinct from NVMe over fabric AFA, right? Because there, if you really look at the market space, right, NVMe AFAs being accessed over standard protocols like Fiber Channel, like block-oriented or iSCSI, and then NFS or on the file side, we're starting to see a lot of interest coming from customers to deploy NVMe-based AFAs, right? That said, the predominant AFAs that we sell are still SaaS-based because of the price premium. The question really comes down to is, at what point does the perceived price premium disappear? And and my belief is that should start to happen. We're starting to see that we're in the early phase of that, but I think the price premium from an AFA perspective between a SaaS AFA and an NVMe AFA will probably disappear next year, right? At which point you should start to see some pretty rapid adoption of NVMe AFAs. Now, contrasting that is NVMe over fabric AFA. Most AFAs today do not provide NVMe over fabric attached or as a target mode. And I think that is partly due to the fact that the ecosystem still isn't there yet. I mean, we're in the early stages of that ecosystem. So my belief is that NVMe over fabric in either target mode or even using it as a client or with NVMe over Fabric JBODs or JBOFs won't happen until perhaps later next year, right? And I still believe that NVMe AFAs will start to see more rapid adoption before we see NVMe over Fabric AFAs.
Excellent. Jason, what are you guys seeing at Quantum on this? What's your view on this question?
Yeah, I would concur with nearly everything that Narayan just said. We're seeing things very similarly. What I would add is I think it's a great question. I present at conferences a slide that shows the total market of storage arrays, and that's broken out by all flash arrays and hybrid flash arrays compared to disk-based arrays. And in 2014, late 2014, there was an inflection point where all flash arrays and hybrid flash arrays basically surpassed the total revenue of disk-based arrays. And since then, and the trend has continued. So now flash-based arrays are nearly triple what organizations are spending compared to their disk-based arrays. Based on the price points continuing to drop, I don't think anyone expects that momentum to decrease. And but as this translates to NVMe, I think that will also have a greater proportion over the overall percentage of what's being spent on flash arrays, and will rapidly probably be over 50% within the next year or two. So the trend is there, the rationale is there, and that's why all the storage vendors are providing these kind of solutions. The market is requiring it.
Yeah, I think the points that both you and Ryan made on the Fabric thing is echoed by our poll, which showed maturity of NVMe over Fabric is one of the bigger concerns that customers have today. Matt, we'll end up with you, and what do you think on this one?
Yeah, well, at the SSD level being the guy in charge and responsible for NVMe, I mean, we've been waiting for NVMe to kick off for years, right? If you've looked at any of the analysts out there, NVMe was supposed to be the year of NVMe in 2017, 2018. Here we are, 2019. But I think with all the offerings that are coming out from the major storage box vendors and the major AFA vendors, 2020 seems to be where the great amount of momentum is going to be forced into the market. And the other thing that everyone's mentioned is the price premiums. NVMe has always had a price premium over SAS, but that price premium has eroded to a point to where there isn't much of a premium between the two. And that is going to greatly accelerate the adoption rate, not only from an end user standpoint, but also from offerings from guys in the market that are selling AFAs. Being able to offer NVMe AFAs at a price point very similar to what a SATA AFA would look like. And the other major adoption point has been the NVMe infrastructure. That's always been a major pain point for NVMe adoption in the market. And as we've said several times during the call, software is really coming around. Driver support is there. Everything's coming around to make NVMe a market word, I guess I call it market bingo term in the year 2020, in my opinion.
Excellent. And okay, with that, we will go to the Q&A, and we have one question. We'll let each of you take a shot at this. I'll start with you, Matt. The question is, I'll read it off, and the question is dual-ported drives have the disadvantage of only having half the throughput available to each connection. I assume that means if you're hitting both sides hard at the same time. The question goes on, I believe I've seen a different approach by Toshiba using Ethernet all the way to the drives with the small protocol conversion IC from Ethernet to PCI Express. What are the pros and cons for the two different architectures?
It's a tough question. Good question. Tough question. We see it as, an Ethernet SSD has some key advantages in that you're basically plugging it into a NIC, and you're able to see the drive, and you don't necessarily need dual port, but even then, if you have a Ethernet router or whatever else go down and you don't have redundant paths, you might miss the drive. You know, the things that for me are going to be difficult for Ethernet SSDs are when you look at security. You know, you have a lot of drives that are on Ethernet that are available to everybody. You got to find ways to manage access to those drives. You got to find ways to manage with encryption on the drive. If there's keys that are being sent out, you got to have a key server available on Ethernet. So there's a lot more protection that you have to put in place from a security standpoint. And
excellent.
yeah, I mean, the dual ported drives, it's not, I mean, it's half the throughput, but it's still a lot of throughput.
Yeah, and I'm thinking if you're using it more from a high availability perspective, that the throughput's probably a lot less of an issue anyway. It's certainly the same total throughput as you have with a single ported drive, right?
And usually with dual port, you know, what we call is a lot of vendors use active passive. So the second port only turns on when it realizes that a redundant data path needs to be made. So the drive may be operating in by 4 most of the time, and then it would, you know, go to by 2 by 2, or sorry, 2 by 2.
2 by 2, right?
Yeah, I
Jason,
think one more point to add is that we run out of bandwidth long before, you know, you can't pull enough PCIe lanes, right, from CPUs to connect to the number of drives available, right? And I think if you look at it from a systems perspective in an AFA, you run out of CPU and PCIe bandwidth long before you run out of aggregate bandwidth coming out of all the drives. So that's another dynamic we're dealing with.
Yeah, that fan out issue is a really good one. That's a great point, Ryan. That is very true. Jason, what are you guys seeing at Quantum on this one?
Honestly, Mike, for this one, I wouldn't have really anything to add in addition to my distinguished panelists here. So, yeah, I just concur with what they would say about this.
All right, excellent. We don't have any other questions. So, again, we will make the recording for this webinar will be available roughly 2 days from now. We'll also make the slides available, and that link will be sent out to everybody who registered. Again, thank you for our sponsoring people, Narayan from Western Digital, Matt from Toshiba, and Jason from Quantum. We appreciate it, and thanks again, and everybody have a great day.